minimal state finite automata means we are interested for obtaining the minimum state DFA, where we have smallest number of states possible. So we are interested for the automaton that should have the minimum number of states. And the last class we have seen, one way to obtain the minimum state DFA is by means of the equivalence classes. Means you need to determine the equivalence classes response to the language of accepted by the FA. And if you find that okay, number of equivalence classes and number of states of your FA are same, then we will say that okay, yes, your FA has the minimum state. If you have more number of states as compared with the number of equivalence classes, then we will see that your FA has the unnecessary many states. And we need to know that if your FA has more number of states, then we also need to know which of the states of the FA need to merge to form a minimum state DFA. So here we are going to see one algorithm which is known as table filling algorithm for obtaining the minimum state DFA. So this algorithm is actually used for identifying the pairs of states PQ for which P is not equivalent to Q. This is the intuition of this algorithm. This means we need to identify the pairs of states of your FA which are not equivalent. So if P and Q are not equivalent, it means you cannot merge. And the pair which is equivalent, we need to merge to form a minimum state DFA. So we are going to identify the pairs which we cannot merge, means which are not equivalent. So this is P is not equivalent to Q. We are going to identify. So this is the FA for the language 01 clean star, and every sentence of this language ends in 10. And we have seen that in the last class, once we have determined the equivalence classes, we know that the number of equivalence classes of this FA is 3, but this FA has 7 states. So we need to determine which states of this FA need to merge. So that's why we are going to use the algorithm for determining the pairs for which we can say that P and Q is not equivalent. If P and Q is not equivalent, then we cannot merge. Okay. So how we can obtain the algorithm? So algorithm, the step 1 of the algorithm says list all pairs PQ. We list all pairs PQ, and this is the unordered pairs, means PQ and QPU means same. So we are going to list all pairs PQ which we consider the unordered pairs of state with P not equal to Q, and P and Q should not be same. This is so how you can list the all such pairs of the states. So how many pairs of this FA has? You have the seven states, and for the 7 states, how many pairs you have? Total pairs you have the 7 by 7. You will have the matrix 7 by 7. In general, if you have the n number of states, then you have the n by n matrix. But every pair is, we are not going to interested. Like if you have, see, if you Q0 and if you have the Q0, if you have the Q0 and this Q0, so this means that if you consider this square, okay, if you have the square like this, so if you have, this is the pair where you have the Q0, and we know that Q0 we are not interested, because we are saying that P should not be equal to Q. So P is not equal to Q. So we are not interested in such kind of pair. And also if you have the like if you have the q6 q0 q6, you can say, and once you go to the upper diagonal of this matrix, then you will have, here you have the q6 q0, and here in this in this corner you will have the q0 q6. So we are interested for the unordered pair, so we are not interested in upper diagonal also. So we are only interested in, so we have this much number of pairs, so we are not going to consider this, and we are also not going to consider this. This is the diagonal, we have, this is the diagonal. Okay, so this is somewhat a construction of the table. So what we have seen, that we need to list all pairs pq which is unordered pair of state with p is not equal to q. So we have seen that q0 we have not considered, q6 we have not considered, similarly q5 we have not considered. So these are the, and also we have not considered the upper diagonal. So these are the pairs only we have. So this is the first step of your algorithm. So if you are given the FA and you need to use the table filling algorithm, then you need to first list all unordered pairs of states for which you have p is not equal to q. The same pair should not, same element should not be there in the pair. This is step 1. Now what you need, actually you have to go to the process. So now what you need to make a sequence of passes. So we need to make the passes. We can consider one by one pairs. So what we need, in first pass mark each pair pq for which exactly one element is in A. And what is A? A is the set of accepting state. So we have A contains what? So here you have the A is the set of accepting state of this DFA, and we have A is actually, we have here Q5. This is the final state. Okay, so what we need in the first pass, PQ for which exactly one element is in A. So we have the pairs like P and Q. So like Q0, Q6, we need to decide final state, and Q6 is not a final state, we cannot mark. So you can come to Q1 and Q6. You cannot also not mark because Q1 is not a final state and Q6 also not a final state. Q2 and Q6 cannot be marked. Q3 and Q6 also cannot be marked. Q4 and Q6 cannot be marked. Now, once you consider the pair Q5, so you have the Q5 and Q6. So you have the Q5 and Q6. This can be marked because Q5, this is the final state. Q5 is the final state, whereas Q6 is not a final state. So in the first pass, what we need to do, you have to mark each pair for which exactly one element is in the final state. If you have more than one final states, then it may be possible that you have the P and Q, and this is also final state and this is also final state for some automaton, then you cannot mark. So what you need to do is, you have to mark the pair for which exactly one element is in the final state. So here we have this Q5. Q5 is the final state and Q6 is not a final state. So we need to mark. Marking means you can make a tick mark, or just I am writing here 1. This means that I am marking in the first pass. So Q5, Q6 I can mark. Okay. So similarly, you can also mark other pairs. Okay. So what you here you can see Q5. Once you go to this, okay, Q5. If this row, if you can consider, then everywhere you have the Q5. So Q0, Q5, yes, Q5 is the final state. So we can mark here. Q1, Q5, this is also in the final state. So we can mark. We are writing 1 means we are marking, identifying that Q1 and Q5 is not equivalent in the first pass. So I am writing 1 pass, denoting that I am marking in the first pass. Q2, Q5, this can also be marked. Q3, Q5 can also mark, and Q4 and Q5 is also marked. So see, we have marked this. Now you can go to this. You can consider whether Q4 and Q0 can be marked. We cannot mark because Q0 is not a finite state. So here you see that Q0 is not a finite state everywhere. And here also so Q0, Q4, we cannot mark. If you consider this, then Q1, Q4 cannot be marked. If you consider this pair, then Q2, Q4 cannot be marked because both are not a final state. Both are non-final state. Here Q3 and Q4 cannot mark because both are non-final state. Again Q3, if you go for the Q3, then Q0, Q3 we cannot mark because Q0 is not a final state and Q3 also not a final state. Here Q3 and Q1 can also not mark. Q2 and Q3 also we cannot mark. So you have to consider pair one by one. Now Q0, Q2 we cannot mark in the pass 1. Q1 and Q2, because Q1 is not a final state, Q2 is not a final state, so we cannot mark. Q1 and Q0 we are not going to mark because Q1 is also not a final state and Q0 is not a final state. So in the first pass we have just marked only the pairs for which we have seen that exactly one element is in the final state. So one state is the final state and other is non-final state. So we have marked, and you can easily see that what we are going to identify. We are going to identify that the pair of state for which P is not equivalent to Q. And you know that if one is final state and other is not final state, so like Q2 and Q5, we have marked Q2 and Q5 because Q2 and Q5 are not identical, are not equivalent. You cannot merge Q2 and Q5. So for taking only one, your FA should go to the Q2, and by taking 1, 0, your FA should go to. So for taking one, your FA should not go to the both places Q5 and Q2. So that's why they are not identical. So one is final state and one is not final state. So they are not identical means we are going to identify the pair for which we say that the pairs are not equivalent. So this is the trivial case in pass 1. What you need to do, if you go for the third pass, so third is sorry, fourth step you can say. This is the step 3, and this is the step say 4. Now in the first pass we are running through the passes. From here you are making a loop. So we are going through the passes. So in first pass it is easy to mark the pair. From the second pass, the next subsequent passes we need to mark all pairs R as. If there is an A, if there is an input such that if you are at the state R and you have the input A for which your FA goes to the P, and if you are at the state S and your input is A, your FA goes to Q, and P and Q, the pair P and Q is already marked. So with the help of the previous marked pair, you are identifying some more pairs which can be marked. So see, like this. If you have the Q0 and Q6, you may need to decide whether Q0 and Q6 can be marked. So you have the Q0 and Q6. So see, you have the input for this case, for the FA, we have the input which is only you have the two symbols 0 and 1. So we have the two input. So we can consider the inputs. Say, if you are Q0, if you are at the Q0 and you have the input 0, where you are going? If you are at Q0 and input 0, you are going to the state Q1, right? If you are at Q6 and input 0, you are going to the state Q5. So from the Q0, your input is 0 and you are going to the state Q1, and Q6 and input is 0, you are going to the state Q5. And you see that Q1, Q5, this is the Q1, Q5, and Q1, Q5 pair already marked. So this algorithm says that you have to mark every pair RS. You need to mark every pair RS such that if there is an A, so you have found the input A for which you are at the state Q0, you are supposed to decide whether you can mark the pair Q0, Q6 or not. You are going to decide for this pair whether you can mark or not. So you have to consider the input one by one. So you have the 0 at Q0, you are going to Q1 in your FA, and whenever you are at the Q6 for the input 0, you are going to the Q5. And in the previous pass, you have seen that Q1 and Q5 and Q5, this is the Q1, Q5 pair already marked. So if this is marked, then you are also going to mark. So you are marking, and I'm writing 2. This means that you are marking in the pass 2. Now you can consider the pair Q1, Q6. Instead of Q0, now you have to consider the Q1, Q6. So you have to consider the all pairs one by one again. So can you decide whether Q1, Q6 can be marked or not? See, if you see that from the Q1, if you are getting the 0, where you are going? You are going to the state Q3. From Q1, you are getting 0 and you are going to the state Q3. And from Q6 on getting 0, you are going to the state Q5. So Q6, you are going to the Q5. And here Q3 and Q5, you can see Q3 and Q5. This pair, this is the Q3 and Q5, and this pair is already marked. So you have to mark Q1, Q6 also. So you are writing 2 here. So Q1 and Q6, you are also marking. Now you can see that whether you can mark Q2 and Q6 or not. So here you have the Q2. So whenever you are at the Q2 and your input is 0, where you are going? From the Q2, your input is 0, you are going to the state Q5. From Q6, input is 0, you are going to the state Q5. So here Q5 and also here Q5, and there is no such pair. Q5 pair is not there. We have listed all pairs for which P is not equal to Q. So Q5 pair is not there. So you can consider other inputs. You can take for the 1, where you can go. If you are at Q2 and getting 1, you are going to the state Q6. If you are at Q6 and for getting 1, where you are going? You are also going to the Q6. So again, Q6 and Q6, both are the same state. So this says that you cannot mark Q2 and Q6. So Q2 and Q6 pair you cannot mark. Now you can decide whether you can mark Q3 and Q6. So say if you are at the Q3, then for the 0 you are remain in the Q3. Okay, so you are deciding whether you can mark Q3 and Q6. So Q3 0, you are remain in the Q3. Okay, and if you are at the Q6 and 0, you are going to the Q5. So see what you have done here. Q3 and Q6, from Q0, Q3, if you are taking 0, you are going to the Q3. From Q6, if you are taking Q0, you are going to the Q5. And Q3 and Q5 pairs In the previous pass we have already marked. So Q3 and Q5 pair is already marked. So Q3, Q6, Q3, Q6 can also be marked. So you are marking in the second pass. Now Q4, Q6, you can consider whether you can mark Q4 and Q6 or not. So see, if you have the Q4, and you have the Q6, from Q4 if you are taking 0, it goes to the Q5. From Q6 if you take 0, it is also going to the Q5. And Q5 is not a such pair. So go for the other input, say 1. So if you are at Q4 getting 1, you are going to the Q6. If you are at Q6 getting 1, you are also going to the Q6, and Q6 is not a pair. So Q4 and Q6 cannot be marked. So you have decided here. Now this is the already marked pair. You are not going to consider this and this also. Now you can similarly consider whether you can mark Q4 and Q0 or not. So Q0, Q4 can be marked or not. So you are going to decide this pair whether you can mark or not, Q0 and Q4. So from Q0 you have the input 0. From Q4 if you have the input 0, you are going to the state Q1. Okay, and if you have the Q4 for input 0, from Q4 for input 0 you are going to the state Q5. So see, Q1 and Q5 is the fine state and Q1 is not a fine state. We have already marked in the first pass. Q1, Q5 we have already marked. So this means Q0 and Q4. So you have Q0 and Q4. You can mark. So Q0 and Q4 can be marked, and you are marking in the second pass. Now you can consider whether Q1 and Q4 can be marked. This pair, Q1 and Q4. So from the Q1, if you are getting 0, where you are going? You are going for the Q3. If you are at Q4 getting 0, you are going to the Q5. And Q3 and Q5 is already marked. So you see that Q1 and Q4. So you have Q1 and Q4 pair, which can also be marked. So this Q1 and Q4 you are going to mark. Now Q2, Q4, you are going to consider Q2 and Q4. If you are at Q2 and getting 0, you are going to the Q5. From Q4 getting 0, you are again going to the Q5. Q5, same pair. Now consider other inputs. If you have the 1, so from Q2 getting 1, from Q2 you are getting 1, where you are going? You are going to the 6, you are going to the Q6, and from Q4 you have the 1, you are going to, where you are going? Q4 1, you are going to the 6, Q6. So Q4 1, you are going to the 6, and from Q2, if you have the 1, from Q2 if you have the 1, then you are again going to the Q6, and Q6 and Q6 are the same pair. This means that you have Q2 and Q4. This Q2 and Q4 cannot be marked. So this is the Q2 and Q4 you cannot mark. Now you can consider this pair, which is the Q3 and Q4. So Q3 and Q4, can you mark? So Q3, if you have 0, where you are going? Again Q3. If you are at Q4 and getting 0, where you are going? Q4 0, Q5. So Q3 and Q5 already marked. Q3 and Q5, you can say that this is already marked. So Q3, Q4 can also be marked. So Q3 and Q4 we are going to mark. So Q3 and Q4 we are going to mark. So you have marked only 3 pairs in here. Now you can go to consider this pair Q0 and Q3. So you have Q0 and Q3. So if you are having the Q0 and 0, you are going to the state Q1. If you are at Q3 and getting 0, again you are at the, you are Q3 and getting 0, you are at the Q3. And Q1, Q3 pair, you can see Q1 and Q3 pair is marked or done. So Q1 and Q3, this is not marked. So we cannot mark here. Okay, if you consider 1, so from Q0 you are getting 1, you are going to the state Q2, and from Q3 if you are getting 1, then you are going to the state Q4. Q2 and Q4, again you can see Q2 and Q4. So Q2 and Q4 we have not marked. So you cannot mark the pair Q0 and Q3. So Q0 and Q3 you cannot mark. So you are not marking. Now Q1 and Q3, we are going to consider Q1 and Q3 now. So Q1 and Q3, if you see Q1 and Q3, then see from Q1 if you are getting 0, you are going to the Q3, and if you are getting 0 from the Q3, you are at the Q3. So Q3, Q3, we don't have such pair in the table. Now if you are getting 1 from the Q1, you are going to the state Q4, and from Q3 getting 1, you are also going to the state Q4. So Q4, Q4 is also not there. This means Q1 and Q3 pair can also be not marked. So Q1, Q3 you cannot mark. So Q1 and Q3 you cannot mark. Now you can decide for Q2 and Q3 can be marked or not. Pair Q2 and Q3. So Q2 and Q3 pair you need to decide. So from Q2 if you get 0, you are going to the Q5, and from Q3 if you get 0, you are in the Q3. And Q3 and Q5 is already marked. Q3 and Q5 is marked. So this means that you are going to mark the pair. Which one? You are going to mark Q2 and Q3. So Q2 and Q3 you are going to mark. So this is you have marked. Now you can consider this Q0 and Q2. So you have the Q0 and Q2. You need to consider this pair Q0, Q2. So if you are at Q0 and getting 1, getting 0, you are going to the state Q1. From Q2 getting 0, you are going to the state Q5, and Q1, Q5 is already marked. So Q0 and Q2 we have to mark. So Q0 and Q2 you have to mark in the second pass. Similarly, you can go for Q1 and Q2. So Q1 and Q2, you see that Q1 0 you are going to the Q3, and from Q2 0 you are going to the Q5, and Q3 Q5 is marked. So you have to mark this pair also, Q1 and Q2. Now we need to consider whether we can mark Q0 and Q1 or not. So Q1 and Q0. So Q0 you are getting 0, we are going to the Q1. From Q1 getting 0, Q3. So Q1, Q3 is marked. Q1, Q3 is not marked. Now consider other inputs. If you are at Q0 getting 1, you are going to the state Q2. And if you are at Q1 getting 1, you are going to the state Q4. So what Q2 and Q4? Q2 and Q4, you can see Q2 and Q4. This is not marked. So this means that the pair, this cannot be marked. So this is the end of the pass second. Now this is because of this updation. Here you may, some new pair may be marked, because once you have considered this pair, you have not marked such pairs. So you may think that, okay, can be marked on behalf of this marking in the second pass. So go for the third pass like this, and then consider again one by one. So if you consider again for the pair this Q2 and Q6. So if you consider Q2 and Q6, so like Q2 and Q6, Q2 and Q6. So if you are at Q2 and you have the 0, if you are at Q2, you have 0, Q5, Q6, 0, again you are going to the Q5. So again, you cannot For the case of 1, if you are at Q2 and getting 1 Q6, if you are at Q6 getting 1, you are again at Q6. So for 1 also, you are going to the Q6 for the both the cases. So Q2 and Q6 you cannot mark. Still you cannot mark. Q4 and Q6 you can consider. Q4 and Q6. So Q4 and Q6. So from Q4 and 0, you are going to the Q5. Q6 0, you are going to the Q5. So both are the same state. If Q6 1, you are in the Q6. Okay. If Q6 and you are getting 1, you are in the Q6. Q4 getting 1, you are in the Q6. So both are the same. So again, you are not able to mark. Now you can consider this pair Q2, Q4. So say Q2 and Q4, whenever you are going to consider Q2 and Q4, for getting 0, from Q4 you are coming to the Q5, from Q2 you are also coming to the Q5, same state. If you are at Q2 getting 1, you are going to the Q6, from Q4 getting 1, again you are in the Q6, the same pair. So you are not able to mark Q2 and Q4 also. And you can consider the pair like this also. Similarly, you will find that Q0 and Q3, Q0, Q3 cannot be marked. This Q0 and Q3 cannot be marked because from Q0 you are getting 0, you are going to 1, from Q3 getting 0, you are coming to again Q3, Q1, Q3, and you have seen that Q1 and Q3 is not marked. You have not marked. For the case of 1, you are going to the Q2, and from Q3 getting 1 Q4, Q2, Q4, and Q2 and Q4 is also not marked. So you are not going to mark Q3. We are not going to mark Q0 and Q3 also. Similarly, you can see that Q1, Q3 cannot be marked. Okay. So from Q1 you are getting 1 Q4, from Q3 getting 1 you are going to the Q4, from Q1 getting 0 you are going to the Q3, from Q3 getting 0 you are in the same state. So Q1 and Q3 also cannot mark, and we have this pair remaining Q0, Q1. So Q0 and Q1. So Q0 is here and Q1 is here. You have already seen that from Q0 getting 0 Q1, from Q1 getting 0 you are going to the Q3. Q1, Q3 is not marked. Q1 and Q3 is not marked. This pair is not marked. Okay. And for the case of 1, you are going from Q0, you are going to the Q2, and from Q1, you are going to the Q4. So Q2 and Q4, you can also see that Q2 and Q4, this is the pair which is not marked. So you are not marking. So you have seen that in the case of the past 3, you are not able to mark any pair. So if you are not able to mark any pair, then actually you need to stop. So what you need actually? So step 5, you need to stop when no new pairs are marked in the pass. So you have seen that in this pass you have not marked any pair, so your algorithm is going to stop. So after once your algorithm stops, then actually you will see that you have marked pair and all the pairs, so the pairs which are marked are precisely those for which P is not equivalent to Q. So you have identified the pairs PQ for which you can say that P and Q are not equivalent. So here you have seen that. Now in this up to here you have identified all pairs for which you can say that they are not equivalent, and also the pair which you have not marked, like the like this is the pair, you have not marked this pair, and okay, and you have also not marked this pair, you have 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 not marked this pair. This means the pair which you have not marked, they are equivalent. So how would you know now which pairs you need to merge and which you don't require to merge? So for this, actually, you need to go to the one final pass. Go through the states of your DFA for identifying which pairs of states you need to merge. You need to go through the states of DFA, like you can start from the Q0. Go through the all states of your DFA, starting from say Q0. Now Q0 is in one equivalence class. So state Q0, we say that okay, this is in one equivalence class, we can say. Now, if you go to the state Q1, now you need to decide, can you merge the state Q0 and Q1 or not? So if Q0, you can keep Q1 with Q0 if and only if Q0 and Q1 is not marked. So you can see whether Q0 and Q1 is marked or not. So Q0 and Q1, you have seen that Q0 and Q1 is not marked. The pair which is not marked, it means the pair which is marked, they are not equivalent, but pair which is not marked, they are equivalent. This means Q0 language corresponds to L0, you have the set of string, and the language corresponds to the LQ1. They form one equivalence class. Now you can go to the state Q0, Q1, then you can go Q2. Now you have to decide whether Q2 will go to this equivalence class or it will go to the different. Q2 will go to the different equivalence class if and only if Q2 is marked with Q0 and the pair Q1, Q2 is also marked. You see that Q2, Q0, Q2 and Q0 is marked or not. So you have, this is the Q2 and Q0, yes, you have marked. And also Q1 and Q2 should also be marked. So Q1 and Q2. So Q1 and Q2. You see that Q1, Q2 is also marked. So Q1 and Q2 is also marked. So Q2 will not go to this equivalence class. Q2 will go to the different equivalence class. This. Now you can see Q3. Now Q3 will go to this equivalence class, or Q3 will go to this equivalence class, or it may be in the new equivalence class. How would you know? Q3 will be in this equivalence class Q0 if and only if Q0 and Q3 is not marked. So see, Q0, Q3 is not marked, yes, and Q1 and Q3 should also not mark. Q1 and Q3 should also, here you can see that Q1 and Q3 pair is not marked. So, but Q3 and Q2 must be marked. So Q2 and Q3, you have seen that Q2 and Q3 is marked. So Q2 and Q3 is marked means they are not equivalent, and Q1 and Q3 is not marked. Q0, Q3 is not marked means they are equivalent, and hence they should go to this equivalence class. This is corresponds to the Q3. Now you have the Q4. Now you are going to consider the Q4. Now you decide whether Q4 can go to this equivalence class or in this equivalence class. So you have seen that Q4 and Q2 and Q4 is not marked. Q2 and Q4 is not marked. It means they are equivalent, and hence it will go to this equivalence class. So Q4 will go to the equivalence class of Q2. So this. And Q4 and Q0 is marked. You have seen. Q0, Q4 is marked. Q1, Q4 should also be marked. Q3 and Q4 should also be marked. They are not equivalent. So Q4 and Q2 is not marked means Q4 will go to this equivalence class. Now see, you have the Q5, where Q5 can go. Q5 will go to this equivalence class, or it may go to the different equivalence class. So see, Q5 and Q2 is marked. Q5 and Q2 is marked. You have seen that Q2 and Q5 is marked. So it will not go to this equivalence class. Q0 and Q5 is also marked. Q0 and Q5 is also marked. Means it will also not go to this equivalence class. Once Q0 and Q5 is marked, then Q0, Q1 should also be marked, and Q0, Q3, Q5, Q3 should also be marked. So Q5 and Q3 is marked. We have seen in the table. Q1 and Q5 is also marked. Q0, Q5 is also marked. It will not go to this equivalence class. Q2, Q5 is also marked. This is, and Q4, Q5 is also marked. So it will not go to this equivalence class also. It means Q5 will go to the different equivalence class. Now you have to see Q6, where Q6 can come. So Q6 and Q4, if you can consider Q6 and Q4. So you have the Q6 and Q4. Q6 and Q4, this is not marked, means Q4 and Q6 are equivalent. So here Q6 will go to this equivalence class. So this is the Q6. So now you have all states are over. So now you have found the three equivalence classes. This is one equivalence class, and this is one equivalence class, and this is one equivalence class. And name, this is say class A, this is class B, and this is class C. So you have three different equivalence classes. So in this case, using the table filling algorithm, we have obtained the three different equivalence classes. So you have obtained three equivalence classes, and you have also come to know that Q0, Q1, Q3. So Q0, Q1, Q3, they form one equivalence class. They are in one equivalence class. So you need to merge. And this is corresponds to the class, which one? Class A. Now Q2, Q4, and Q6. So Q2, this is Q2, then you have the Q4, and here you have the Q6. These states need to merge, and they form one equivalence class. Say this is the class B. And state Q5 will be in only one equivalence class. So you have the state Q5 is in one equivalence class. Say this is in equivalence class C. So using the table filling algorithm, you have come to know that how many equivalence classes. You have identified the three equivalence classes, and you come to know that Q0, Q1, Q3 states need to merge. Q2, Q4, Q6 needs to merge to form one state, and Q5 will remain in alone. So you have three different states here. So here you have found that your FA, your given FA was having 7 number of state, but by using the table filling algorithm, you come to know that you have actually this FA should have the 3 number of states. So it should be A, B, and C, where C will be the corresponds to the final state, and A is the initial state, and from A you know that you are 0, you can construct the FA. From A you are getting 1, you are moving the Q2, and Q2 is in the equivalence class B. From the B, for the case of 1, if you are B is, you are in the state Q2, B, and getting 1, you are going to the Q6, and Q6 remain in the same equivalence class. So that's why you are remain in the same equivalence class. From B getting 1, you are going to the state Q5, and state Q5 is in the equivalence class C. From C getting 0, if you are having 0, from the C you are going to the Q3, and Q3, if you are at Q5 getting 0, you are going to the Q3, and Q3 is in the equivalence class, where Q3 is in the equivalence class A. So this is 0. Whenever you are at the Q6, so means Q5 and getting 1, if you are at the Q5 and you are getting 1, you are going to the state Q4, and Q4 is in the equivalence class B. So you have the B. So this is again you have the obtained the FA. This is the FA. This is the FA having the three states only, and this is the minimum state DFA. This is minimum state FA. This is the minimum state FA. Okay. So in this way, we come to know that how we can obtain the minimum state DFA by using the table filling algorithms. You can come to know that table filling algorithm is more systematic way as compared with the equivalence classes. So in as you have in case of determining the equivalence classes with the help of the given language accepted by the FA, if you use the table filling algorithm, this is more explicit way to determine the equivalence classes. So, but this algorithm is also not a simple one. If you go for analyzing the table filling algorithm, the conclusion is that obtaining minimum state DFA is computationally hard problem in computer science.